Hi, my name is Don Wilson, and I am here representing Team 14, the IoT Lifeguards. Our project is the IoT Lifesaver, a device designed to prevent drownings in swimming pools. I am largely responsible for the FPGA development of the project. Since last video, I've nearly completed a SPI interface required for the pressure sensor used to detect depth. And to be completed is a I2C protocol required for the gyroscope. I've also created a very simple prototype using a Arduino Micro in order to make sure everything was going to work as planned. Here to talk about the circuits is Sam.
Hello, my name is Samuel Capend. I'm a part of Team 14 working on a circuit part. So since last video, I've been working on a circuit of the wearable devices, and I implement the schematics and working on a 3D model by using a open source CAD and then open source version of Cadence to make the schematics. So as you can see, I designed the wearable 3D mode enclosure, which is gonna house all the FPGA, the pressure sensor, the gyroscope sensor, and the RF module. So since the last video, as I say again, after we receive the parts, the pressure sensor, the wireless inductive charger, I did an initial testing of all of them, and they successfully work according to the specification. And from the next part of the project, I'm gonna be fine-tuning the schematics to make sure that all the inputs coming from the pressure sensor and the gyroscope match with what is the FPGA gonna be receiving. And so for that, as with that all being saying, I'm gonna pass it to Hai, gonna talk to you guys about the RF portion of the project. Thank you.
Hi, my name is Hai Tran, and since the last video report, I've sought out to test multiple communication systems, specifically Bluetooth 5 and 433 megahertz module. And I found that the 433 megahertz module had greater success in transmission underwater compared to Bluetooth 5. This reason being is the Bluetooth 5 had a greater frequency of 2.4 gigahertz, which has a smaller wavelength compared to 433 megahertz. So therefore, we've proceeded with the 433 megahertz and found that with an antenna of 17.3 centimeters long chord wavelength, we're able to get about 2 feet underwater. We're hoping that after implementing error correcting codes to get it to about 5 feet underwater. The next task for me will be implementing a more sophisticated antenna design in order to improve the extension of the transmission underwater. To talk about the software side of the project, here's Scott.
Hi, so my name is Scott Weston. I'm in charge of all the software components of this project. So since last time I watched I did a learning tutorial on React Native basically over the Christmas break via the learning platform Udemy. From this, I was able to walk through a sample project, and from that I was able to basically make a rough framework of what our app would be. So it's basically a list. You choose something on the list, and ideally, once we have all the sensors configured, there will be a graph that will illustrate the sensor data. Once this was done, I switched my focus to AWS to focus more on functionality over presentation for the POC. And so in AWS, I basically have created a mock data bridge so that when we actually do finish the board with all sensors, it'll be easy to plug it into the software backend. So to create this bridge, I used a tool called Node-RED and basically simulated data through an open port on my computer. I sent this to AWS IoT Core, which I picked it up and sent it to IoT Analytics. In IoT Analytics, I have 2 Lambda functions, one in Python 3 to handle the data and make it look nice and combine it and whatever we want to do with the data. And then I basically, to get the data from AWS to the app, I needed 2 API endpoints. To do this, I used another service called AppSync. And so that second Lambda function will take the data, put it in a DynamoDB database while publishing that change to AppSync. AppSync will take that change and then send it to my client application. And so in that way, I'm able to get data all the way from IoT Core into the actual app in the user's hand. And so what I plan to do next is, now that I have the data in the user's hand, I plan to make it look nicer through visualizations and graphs, and work on that Python function once we actually do get real data streaming through there. So with that, that's the end of our video.